Hi everybody, Big Nate here again. I have a project I'd like to share with you. It's a sub-project that has to do with a larger, longer-term project that I'm working on at the moment. But first, I'm going to share a little bit of my personal background with you. I have a background in aerospace manufacturing, and I also have a degree in robotics and electronics. And what that means is that I'm constantly thinking of little projects to work on in order to use those skills that I have. And in this case, I went looking for a way to manage the boost on my turbo project and not spend a ton of money doing it. I didn't find a solution that I liked, so I've decided to go ahead and move forward with making my own boost controller. In the past, I've made solenoid controllers. I've done all sorts of different robotic systems, running PLCs. In this case, I'm going to go ahead and use a GM 3-bar MAP sensor and use that in order to get the signal needed to control the MAC valve that's going to control the pressure on my wastegates. And I'll make another video on that one some other time. But for right now, I would just like to show you this little project I'm working on using an Arduino to map out the GM 3-bar MAP sensor. All right, everybody. First thing I'd like to do is do an overview of all the bits and pieces I will be using in this project and explain to you what each one does. Here on my breadboard, you can see that I have the GM 3-bar MAP sensor hooked up. I made some test leads using some weather pack connector material onto my breadboard wires. I'm using an Arduino Uno. I got 4 push buttons that are not being used at the moment, but that's for a future project. And then I'm using a OLED display, to act as my display. The map sensor that I'm using is this one that I got off of Amazon. It's a 125/925/25 3-bar map sensor, sometimes commonly referred to as a 2.5 bar. We're going to test that out today and see exactly what voltages get us what. In addition to that, I have an air source, which is this pressure tank with a mechanical pressure gauge on it. And then my old trusty pressure regulator, 0 to 30 PSI. And we will be hooking that up to the map sensor directly and then reading what voltage we get at a given pressure as read on the pressure regulator. All right, everybody, I have it hooked up. I have the pressure regulator pushed into the GM 3-bar MAP sensor. I have my sketch on the Arduino running. Right now at 0 PSI, I'm getting about 1.79 volts. So I will put that in my spreadsheet. I'm going to comment that that is current baro, because that should not be perfectly sea level conditions right now. We're a little bit elevated. We've got a storm blowing through, so I'm thinking that we're a little elevated today. So now I'm going to go ahead and start cranking it up. And we're going to go to 5 PSI. There it goes. Starting to climb. More. right, 5 psi, and we're getting about 2.41. Yeah, we were getting about 2.4 at 5 psi. Significant figures don't matter too much. Now let's keep increasing the pressure. Let's go to 10 psi. There's 10 psi, and we're getting about 2.96. Let's keep cranking. I'm sorry if the mechanical gauge is blurry, but I can't focus on both at one time. We're looking at about 15 psi and 3.54 volts. Now let's go up to 20 psi. Let's get up to 25 psi. We're going to 4.66. All right, now I want to be careful. Does appear as though we have reached the limit. 4.72 seems to be the limit of voltage. Doesn't matter how high I turn it, we can't quite reach 30 psi. Let's see when voltage starts dropping, what our gauge tells us. So we're right around 27. Let's crank it back up here. Yeah, about 27 psi. All right, now I am back. I have done some mathematics and some more coding, and I have managed to get the map sensor calibrated more or less so that my digital readout is matching the gauge pressure on the pressure regulator. So now I can show you how this all works. Right now, it's sitting with no pressure going through the pressure regulator at all, so we're getting about 0 psi, give or take. I've done some coding so that we can actually switch over and take a look and see what the value is in kPa as well as in psi. And right now it's kind of bouncing around a little between 99.9 and 100 point whatever. I verified that with current barometer reading, and we are sitting at about 100 kPa right now. Go back to psi, and you can see that as I increase the pressure using the pressure regulator, that the reading on the digital pressure is increasing. We can take this all the way up. I haven't been able to get all of the air out of it. Error, not air. So there is still a little bit, but at 15 psi, it comes pretty close to matching what is on the mechanical gauge. I have noticed that this mechanical gauge is actually a little bit laggy. Right now we're getting about 15.1 psi on the digital gauge and The mechanical is showing, roughly more than 14 and a half. If I give this a little bit of time, they're going to equal out to each other. I actually believe that the mechanical gauge is a little bit sticky. I noticed that especially when I turn it way down. You can see it's kind of jittery there. It jumps a lot. So let's go ahead and crank this all the way up to 25 psi, which is just shy of maximum. That matches pretty good. And we can switch over and take a look at the KPA reading, and that matches up pretty good. And so far, so good. So I'm reading a 3-bar GM ZR1 MAP sensor in both KPA and PSI, using an Arduino, verifying it with a mechanical gauge. And I think I am ready to move on to the next part of this project, which is going to be taking this little guy here and making him functional, and then doing some really fun math and controlling a wastegate to meet a set pressure. So that will be another video for another time.